I've gotten rid of Hawkins at the
Oh, yeah, okay. Just up there.
So if you go up and then that way, there's like a sync with monitors and tabs.
Oh, yeah. Thanks, mate.
Cool. Okay, folks, we're going to get underway. We've got, thanks so much for turning out in such great numbers. Really big thank you to Itzik Feldman and Rowan DePellier from Atlassian for hosting us tonight. Always thanks, mate. Really appreciate coming back here. It's the guy in the green shirt up the back there. So yeah, it's always really great to come back to Atlassian because I think we've been probably Atlassian have been hosting us. I think they were the second to host us, and we've been coming back for about 5 years, bar the 3-year pandemic gap. So it's pretty good to be here. Steve Lee, one of their principal data engineers. They must have 5,000 principal data engineers, but you know, it's a big company. But he's got a super impressive talk tonight about Waterwheel. A bit of like, you know, solve some of the challenges at scale with, Apache Airflow, which that's going to be really, really interesting. So really cool to see what happens in this space. And then we've got John Hawkins. He's a data scientist, but he's going to talk to us about feature engineering. So we won't hold that against him. Yeah, absolutely most welcome. Thanks so much for putting together this talk at such a short notice. But without further ado, I'm just going to hand it over to Steve, and you can get us underway. Thanks so much.
Hi, thanks.
Round of applause.
So today I'll be talking to you about Waterwheel, which is a data engineering job scheduler. So who here has heard of Airflow? Okay, that's good. Pretty much everyone. Okay, that makes things a little bit easier. Who likes Airflow? Oh, I expected a few more hands than that. I like Airflow. Who loves Airflow? Yeah, okay, that's kind of what I was expecting. Yeah. All right, so first of all, we'll just take a step back. What actually is a job scheduler? So it's not just cron. A job scheduler does more than what cron does. So in particular, these are some of the things that I think sort of distinguish a job scheduler from just cron. So it runs on time periods. It doesn't just say, I want you to start running a job at these specific times. It's more about dividing up time into fixed or into periods, chunks of time, and running a job for each of those chunks. The difference between that and what something like cron does is when you have catch-up and backfills. So with cron, if your computer shuts down for a week and starts back up again, it doesn't do anything. It doesn't run for all of the days that it missed. It also can't do backfill. If you say, I want to create a job and I want it to start at the beginning of the year, that's not something that cron can do. The job scheduler handles these cases. It will run a catch-up if there have been periods missed, and it will also run backfill. You can say start from the beginning of the year and it will run for each period to catch up until today. Reruns. So a job scheduler should keep track of what it has run in the past and allow you to selectively rerun periods. In particular, if a period has failed, you want it to retry to succeed. But other times, there may have been dodgy upstream data, and even though the job succeeded, the output was junk, you want to rerun it. Job schedulers also tend to use directed acyclic graphs or DAGs. So rather than just running a single task at a time, it actually runs a graph of tasks with dependencies between them so that you can coordinate multiple steps. They should provide some level of observability, so typically a web interface, but also it's nice to emit metrics to something like SignalFX or StatsD or something like that. So you can actually see what your jobs are doing, how they're proceeding, how long they take, those sorts of things. And the last one, it may be a little bit subtle, is secret management. So in particular with data engineering, we often need to connect to remote data sources like databases, or you need to contact APIs from various things like Salesforce, whatever. You need some way to securely store the secrets used for those connections. So that's what I think are the important things for a job scheduler. So I'll give you a bit of an overview of how Waterwheel is structured. So it manages a set of projects. The project is used for access controls. So you can grant users access to use a project. And secrets that you store inside Waterwheel also get scoped or can be scoped to a project. So if a particular team has a database that they need to use, you would store that database password in that project so that only that team can use it. Inside a project are jobs. So each job is, well, I guess that the job is the unit of update. So when you want to update something, you have to update a whole job as one unit. That'll make a bit more sense in a moment. The job itself is a DAG of tasks and triggers. So triggers start execution of a job based on a schedule, and then the tasks actually perform the job, the work. So when I'm saying the unit of update, if you want to edit a trigger, you actually have to edit the whole job that trigger is contained. So that's sort of the unit. If something doesn't validate, the entire change is rolled back. You can't update just like a single task or a single trigger. So how does Waterwheel actually execute? You can see my lovely little GIF animation that I made. So it's based on this thing called a Petri net, which is a formal modeling technique from, I think, the 60s. Don't need to know the technical details, but the concept behind the Petri net is that it's a graph. Each node in the graph has tokens on it. When the node reaches a threshold, it fires, some action happens, and then it puts tokens on the outgoing edges into the nodes that they point to. So here you can see, I've just missed the start of the animation. The first node up here will receive a token, and it will start executing the circle. When it succeeds, it will put tokens on these two nodes. They then start executing. When they succeed, they place a token here. This one places a token here. You can see my mouse right here. This node has a threshold of 2, so it won't execute until it has received 2 tokens. And this node only has a threshold of 1. So this is the basic concept. This is how Waterwheel keeps track of what's running and what's still waiting to run. Each task has a threshold, how many tokens it needs to receive before it can start. So this is quite in contrast to the way Airflow works. It's not as flexible as what Airflow allows, which is like you can have one upstream task succeeded, one upstream failed, all succeeded, all failed. There's all complicated ways. But the difference here is that this way is much, much more scalable. When a task completes, we can very quickly evaluate what task should be started next. So that allows Waterwheel to scale much more quickly. All right, has everyone seen the animation enough times? Yeah, cool. So in Waterwheel, jobs. So each job is defined as a JSON document. As I said, the job is updated as a unit. You submit the entire JSON at once. However, you'll see that on this slide, that's not JSON. My suggestion is that you may want to construct the job JSON from some other format that's easier to read. For example, you may want to use YAML or I don't know, JSON5, TypeScript, whatever. Anything that you can convert into JSON is fine. Are we able to ask the people at the back, thanks, to be a little less rowdy? Sorry. Okay, so the job, obviously the most basic thing, it has an identifier, the UUID, and then it has the name of the project it is contained in, and then the job itself has a name. A description, and then a flag to say is it actually running, paused or not. So the next thing down in the YAML or in your JSON file is the triggers. Each trigger has a name, a start date, optionally an end date, and then the period. So the period can be specified as like a duration string, like 1 day or 1 hour. You can do like, 37 minutes if you want something really precise. You can also use cron if you want something that's more complex, like the first day of the month or every Wednesday. I find generally doing period, if you can get away with period, it's a lot easier to understand, just like daily is 1 day. And then finally, the catch-up determines what happens for skipped periods. So catch-up latest says start from the most recent skipped period and work backwards to the oldest. There's also earliest, which will go from oldest forward, random, which will do them randomly. There are valid reasons why you might want to randomize your catching up. And then catch up none basically says just ignore them. Just skip those periods, don't catch up on them. The next thing down is the tasks. So each task in Waterwheel is a Docker image. You can provide arguments and environment variables to your Docker image. So the intention is that all the logic of what your task needs to do is packaged up into an image, self-contained unit. It avoids a lot of the issues about like deploying dependencies onto your workers because they don't need to be deployed. The worker just runs the Docker image. The task also then gives its list of dependencies. So if you do a dependency like this, trigger/daily, that means that this task will begin when the daily trigger fires. So that is referring to this name up here. Then obviously you can depend on other tasks. So step 2 depends on task step 1. And then we have a task called fail, which has depends failure, which means that it will actually trigger when the upstream dependencies fail, not when they succeed. And in this case, I've said step 1 and step 2. The threshold that I talked about earlier, the number of tokens needed, is determined automatically. You can override it if you want, but it is automatic most of the time. It is the number of successful triggers, if there are any, successful dependencies. So in this case, it would be 1 and 1. If you have failure dependencies, it defaults to 1. So 1 failure will trigger a task like this. So you can do some complicated things simulating some of Airflow's capabilities, like you can have 2 upstreams but only have a threshold of 1. You can do complicated things like that. So now here's one of the first features that is going beyond what Airflow can do. The complex task dependencies. A task can depend on any other task. It can be in a different job. It can even be in a different project. So this is quite powerful, and you do need to use it with care and caution because you can end up with a horrible sprawling mess if you go overboard. But the intention here is that you can have a job. Typically, you would have a step at the end of the job that would say, send off a success email or, some kind of finalization step. You can then have another job which depends on that task, so that when the first one finishes, the next one will start running automatically. Airflow simulates this kind of thing using the external task sensor. Seems like a bit of a hack because obviously it wasn't designed to work that way from the beginning. There's a lot of caveats with using external sensors. So this, however, is built into the way Airflow works. When a task completes, it looks through to see all of the tasks that are downstream of it and places tokens on them. So there's no special weird logic. This is just the same as any other dependency between tasks inside a job, between jobs, between projects. It all works the same way. So between projects, you probably want to use sparingly. Between jobs can be quite useful if you have very distinct units, but you need to chain them up to have incidents. Task offset dependencies. This is a very advanced feature. I'll very quickly explain it. So if you have a job that, let's say you have a job that is triggering at midnight every day, and you have another job that you would like to trigger at 3 a.m. But the 3 a.m. job needs to make sure that the midnight job is finished. The midnight job should take less than 3 hours, but sometimes it doesn't. Sometimes it goes over, there's a delay or whatever. What you can do is you can say that my 3 a.m. job, it depends on its trigger, so it starts running at 3 a.m., but it also depends on the other job. We have this syntax at 3 hours. So in other words, 3 hours ago at midnight. So basically what that means is that if the upstream job has finished, this job will receive a token at the 3 a.m. mark, but it won't actually begin until the 3 a.m. trigger happens as well. So if the upstream job is running late, it will wait until that token arrives. But if the upstream job's finished, it just starts on time. So that's something that's quite hard to simulate with Airflow from what I've seen. Anyway, advanced feature, probably don't need to worry too much about. Some of the advanced triggers, trigger offsets. This is one that is more just, I suppose, a niceness feature that I feel is missing from Airflow. Sometimes you want a job that logically runs at midnight because it's scanning data, for example, between midnight and midnight, but you actually don't want it to start at midnight. You want it to wait a bit, like 3 hours, for example. So in that case, you can set the start time of midnight, but then offset 3 hours. So it means even though the job logically is running at midnight, it won't actually start until 3 hours later. And then, as I mentioned earlier, there's the catch-up, earliest, latest, random, or none, the options for catch-up. So stash. When I was talking earlier about secrets, Waterwheel has a more general process. It's not just for storing secret data, you can store other kinds of data too. So you can stash values into Waterwheel either globally at the scope of a whole project or at the scope of a single job run. The job run scope is essentially replacing Airflow's XCOM mechanism. So whenever a job is running, it can stash their values, and other tasks within the same job can then read that value back again. So each time the job runs, it gets a different stash so that the values don't clash with one another. So you use that, for example, if your first step starts up a Databricks cluster, you might want to run a cleanup step at the end to make sure that that cluster has been shut down. And you would store the cluster's ID into a job run scoped stash. The project scope stash, as I said, will be for like database passwords. Global stash would be if there's a database that everyone has access to, or you could use it for things like if you want to deploy Waterwheel in staging and prod, you could stash the environment type as a global stash value. To retrieve the stash value, when your Docker image is launched, it's provided some environment variables. One of those is a bearer token, which gives you permission to read the stash that is scoped to your job project. Your job app project. So you can't read random other project values if it doesn't like it. All right. Deploying Waterwheel, sort of the architecture of how it actually looks when you run it. There are three main Waterwheel itself has three main components. There's an API server which serves the web interface and also provides the APIs. So this one is stateless. You can run multiple copies for availability and scaling. There is a scheduler which monitors the triggers and launches or triggers them at the appropriate times. The scheduler also performs the checks when a task finishes, it launches the following tasks. The scheduler is not stateless, however, it uses a clustering algorithm, so you can run multiples at once. They will share the triggers roughly evenly between themselves so that you can scale up to large numbers of triggers. If a scheduler crashes, they rebalance themselves. Some great open source libraries out there that can do these kinds of things. The last component is the worker. The worker obviously performs the work. It actually launches the images and monitors them. The worker is stateless and you can run multiple copies of that as well, obviously, to scale up. So there are some other components that you need. A database. The database obviously stores all of the data. so that the job definitions, but also the status of all the runs and so on. And then finally, AMQP, which the recommended would be RabbitMQ, is used for communicating between all of the different processes. Yep. So the worker has two different modes at the moment. You can either just directly run Docker images. So that's great if you are developing locally or you're just trying to test something. You just need to have Docker installed on your local machine. You could also use the Docker worker if you want to deploy onto like their hardware or a PC2 or a VMs or something like that. The other worker is Kubernetes. So if you have Kubernetes infrastructure already, that's probably the best option. It has the most resiliency properties, better than regular Docker would. Obviously, a lot more complicated if you don't have Kubernetes infrastructure, but it's available. So Waterwheel itself, one of my goals has been that it should be really easy to run. We don't want complicated installation processes and huge amounts of configuration and environment setup. So it is distributed as a single binary. It's written in Rust for anyone who cares. There's two basic commands. If you're running locally, you can just do Waterwheel server. That gives you a single scheduler and an API server all in one. You don't have to run two separate processes. They can run together. And then Waterwheel worker will launch a single worker. They take all their configuration from environment variables or the .env file, or there is a terminal file as well if you prefer. These are, I think roughly, these are the only mandatory configuration values. Database, obviously because I don't know your database password, you need to provide the database URL. Server address is complicated and I'm not going to explain that. And no auth-c just says, I'm running locally, disable authorization, just let me do whatever. So if you're testing locally, you probably turn that on. I didn't want authorization to be off by default because that's generally a bad idea for security reasons. So you have to explicitly opt out of authorization. All right, demo. Fingers crossed. Let's see what happens. Actually, that's a quick presentation. All right, so I believe I've got the database and all that stuff already running. So it should be a simple case of running Waterwheel server. Can everyone actually see that, or is that too small? I can try to zoom, but I have no idea if it's going to work. Yeah, I don't actually know if I can zoom this one.
Command plus doesn't work?
No. Oh, no, it does. You learned something new. Control plus works. Okay. Great. I didn't even think of that, sorry. All right, so Waterwheel server, we'll just launch the server. It prints out a bunch of stuff. At the moment, everything's blank, so nothing is happening. So I will go. This is the project. So first you have to declare a project, which is a JSON object. I can also make that one. That one's not control plus, apparently. Oh, it's control equal. That makes sense. Okay. So that's the project JSON file. And I've just got a command to put to API/projects. So I'll just run that. And yep, created. We go back here. The project has been created here. So we can go into our web interface. Just like that. Okay, so one project, projects, and there it is. It's empty, there's nothing in it. I can also make that. So now, the next thing, I will create a job, which is, so this is a sample job that I've just put together. You've seen all the fields before, so I'm not going to go through everything in great detail. Essentially, step 0 will echo Waterwheel is working. Step 1 will run a custom Waterwheel random is an image that I've created. The reason it's called that, it's a very basic Docker file. From Python, it installs requests and adds a single main file. The main file sleeps for a random amount of time, just prints out some messages, and then it exits with a random exit code. 5% of the time it fails. So it's just a random workload. So I will create, so here we put two API jobs. And create it. So now you see it's a created job, single job, and it's printed sleeping 50 seconds until the next trigger. And we can see the reason for that. Catch up is set to none, so it has just ignored the start time and it's just set start now. The period on this is 1 minute, so it's going to run roughly every minute. If we go now in project, we'll see we have a single job. You can click on it and we have a wiggly graph of what your tasks look like. I really don't like that, but I haven't found a better library. Like I just want it to show in a straight line, you know. Anyway, so then there is some other views. So there's the overview view, just gives you just running, waiting, succeeded, all those stats. I'll come back to the grid view. The trigger view tells you that it's got one trigger, it runs once a minute. This is the start time, the most recent time that it triggered. The token view gives you the list of all of the tokens that currently exist. So if you want to see what is this job doing right now, the tokens is where you would look. Active means that it has been sent off to get executed, but it hasn't actually started executing yet. And running obviously is when it starts executing. Duration will be blank now because nothing's actually run, and definition just spits back the same JSON so you can see what the job does. The grid view is like that Airflow boxes screen. However, something close to my heart, it's colorblind friendly. It doesn't just use colored boxes, it actually uses icons, so you can see. Yeah, pet peeve of mine, drives me mad. Okay. So you'll see as well, we've got some more logs. Task enqueued means that it's pushed off a task into the queue to be executed by a worker. Slept 59 seconds until the next trigger, and that's enqueued another. So we need to actually start a worker. When we start the worker, we'll see that it's received those two tasks already. Back to here, we'll see that those two tasks succeeded. They just echoed Waterwheel is working with view logs in tab. We can see it echoed the log. And now step one is running. I need to click on it and then go logs in tab. And we'll see it's already finished. It's slept for 25 seconds, that one. Yeah, and both of those have succeeded. So every few minutes we will see a new line. There's another one. Click on that. Logs in a new tab. I want to catch one that's actually live. Quick, there we go. So the logs tail back live as well, so you can watch them. This is a relatively new page, so it's a bit unfinished yet. What else do I need to go through on this? Yeah, so the project view also just gives you an overview of running and succeeded for each job in a project. I can show some of these other tabs. So there's a tab, the workers tab shows you all of the workers that are currently running, as well as ones that were recently alive and have disappeared. We can click into that and you can see like all of the tasks that this worker has run and details about when it got queued, when it actually started. So how long was it stuck in the queue waiting? How long did it actually take to run? So all those details in here. The schedulers tab, because I'm not running in high availability, that's just one scheduler. It tells you which trigger is next in line. I'll go back to projects and we will create the next project. So the next project is the complex one. I've used the YAML format just to show you what it looks like. Cron syntax, run every Sunday at midnight. This one runs the same random task, but it runs it a whole bunch of times with various different complicated dependencies between them. This is sort of the stress test that I've been using. And if we create that one, Okay. This one I actually did set to catch up, so we should see that it should already be running some stuff. So in the grid view, you can see all of the step A's are running. As tasks complete, more columns appear, and yeah, it'll slowly fill in over the next few minutes. So this page updates pretty much live, like half a second delay. Duration tab shows you a little graph of how long each step has taken. That's only showing step A. It's weird. That's some other steps finished, so you can see the random sleeping means that they're all roughly different times. Yeah, so that will just keep going on its own for a little bit. Now, the last feature, I think, in the demo is so the cross-job dependency. So this one, we have a step that actually depends on another task in a different job. So this one actually doesn't have any triggers. Nothing starts it on a time-based schedule. It just waits for something to happen in another job. So if I create that one, so what we will probably see, I think I've waited too long to trigger it. Oh no, there we go, there's something that started. So as, I think it was step, which step was it? Step B3, oops, drag that into step B3 and step E. When B3 and step E complete, we should see jobs getting triggered over on this side and starting to run. I'll just let that finish for a bit. I think that's it for the demo. The only last thing was there's an API to pause a job, but that's not super exciting. Yeah, so while we just wait, were there any questions? Yes.
Do you see support for something like providers coming in at some point, or is the preference to just go down shell scripts?
When you say providers, you mean like in Airflow, how you can install like packages?
Yep.
Yeah, so the intention is that providers would be sort of distributed as Docker images. So if you wanted, for instance, let's say a Databricks provider would actually probably be a Docker image, like a Docker base image that you would say from Databricks provider, then you would copy in your SQL code or your PySpark or whatever code it is, and then deploy that Docker image into Waterwheel. So it avoids a lot of the issues. You don't have to synchronize versions between different teams because each of them build their own image that's self-contained. They can have different versions of that base image included. You basically, you give a bit more autonomy to the people running the jobs. They don't have to say, oh, can you install this new provider for me onto Airflow? So the bit that I wanted to demo, there'll be more time for questions at the end, assuming I'm allowed this time.
Very interesting.
So if we click, for instance, on this one and we say, actually, that job, I want to start it again because the upstream was dodgy, you can click activate. You'll see down here, it starts a second attempt. Because I clicked it manually, it automatically goes at high priority, so it'll push in front of the queue of anyone else. Backfill is the lowest priority, then there's just normal scheduled jobs come up at normal priority, and then high priority for anything where someone says, I want to run this now. So step A will run. We can view the logs and see that it's not. Okay, so now it started the B steps. And what we should see in a moment, can actually pull that out. Yeah. We should see when the B steps start, the cross-job dependency will automatically start as well. So I don't need to know if there are teams that are depending on my outputs. I don't need to know about them. I don't need to tell them, oh, you should rerun your job because I'm rerunning mine because of something upstream. I can just say, rerun my job, and all the downstream jobs will get rerun automatically. Did it run? I didn't see it. Oops, I wasn't looking. Step one. Oh, I didn't do it. What's happened? Anyway, it may not be working. I will have to investigate that. It should work. Anyway, yeah, so the external task sensor in Airflow, there is a way you can do it where you can actually have a step that explicitly triggers the downstream jobs. But again, this is built in. It's designed to do it from the start, so it just works in theory. Oh, look, there we go. There is an attempt to at high priority. So that's because I triggered it. It automatically triggered the attempt to. Yeah, so that's how that works. Just check. I think that was it. Yeah. So code is open source on GitHub. There's the URL, and you can scan the QR if you want to jump straight to GitHub. Yeah, if there's time for questions, ask away.
A round of applause first. Any questions?
See, that was really impressive. That's
Thank you.
seems that you've addressed so many things with that. It's like the UI is fantastic.
I'm not a UI designer. I hope it's not obvious.
But yeah, just curious. So who's this developed here at Atlassian? And so
Not technically. It has been developed in my own time.
oh right.
I did during Innovation Week. I deployed it into Atlassian, but not technically developed at Atlassian. We're not currently using it in production at Atlassian. It's a bit of a hard sell for a company this size to take a risk on something like this, but I'm really hoping that with a bit more support from other people that maybe one day it would be accepted. So yeah, it's not developed at Atlassian. However, a lot of the features you may have noticed are specifically things that have annoyed me or have been causing us problems here at Atlassian.
Can you share a bit more about those problems? And like you mentioned, the XCOMs is the main thing that is addressing.
So there's a few main things. I didn't really want to bash Airflow too much, but I'll try to be nice to them anyway. So the first one, definitely secret management. Like Airflow has variables and connections. They are essentially global to the whole Airflow installation, which means it's very hard to share an Airflow between different teams, especially if you've got something like a password with access to Salesforce. We have had issues where teams are like, how do we stop someone else from just using our connection? And we said, well, you can't. You'll have to actually have a separate Airflow if you need that level of security. So that's one of the first things.
Sorry, how does it address?
How does it address that? So the secrets in Waterwheel can be scoped to a project, and when a task tries to request a secret, if you try to request a secret from someone else's project, it's denied. You won't be able to retrieve that value. So yeah, essentially each project secret is only allowed to be used by jobs within that project. And then access controls are then used to make sure that other people can't put tasks into your project. Yeah. Yes?
Because do you have any enhancements coming up? If you actually want to help with any of those enhancements?
Yeah, so the question was, do I have any things that I would like help with or enhancements? There's a bunch of things that are in the back of my mind. A lot of them, it's sort of just polish. There's parts of the user interface which are still a little bit tricky to navigate. As I said, I'm not a UI designer. So there's always work to be done in that front end. In terms of back-end features, there's a few things that are maybe not small, like at the moment there's no built-in retry mechanism to retry a failed task automatically. That's something that I would like to be able to do. Weirdly enough, you can simulate retries just by having a graph that's not acyclic. You can actually have like a token that travels around in the loop until it succeeds. That's something that Airflow does not let you do. Yeah, I have a roadmap page with some other ideas, but at the moment I've kind of been trying to finish off all the things on the page first and not start talking about new features. But yeah, definitely, if anyone would like to be involved or would like to contribute, I'm happy to help out and get you onboarded. As I said, it's written in Rust, which is mostly because of the partly performance. Python is not great. It's not the limiting factor in Airflow, but it's not helping them. It's mostly for correctness. So Rust means that I can confidently write a complicated, like it's multi-threaded concurrent system without worrying about weird race conditions and those kinds of things. So if you're interested in learning Rust at the same time, then come on board.
Oh, Simon, yeah.
Oh, super quick question. I was wondering if you knew what the adoption was like.
Of Waterwheel,
Yeah.
it's exactly 0 as far as I'm aware. Yeah, I haven't really been putting it out there much yet. I've been trying to make some inroads here at Atlassian. As I said, it's risky, and Atlassian are not really comfortable taking that risk at this moment. So that's part of the reason I'm here tonight.
Yeah. On that point, Steve, would it be worthwhile to the rest of you if, say, we create a Waterwheel channel on the data engineering site group so that, we can sort of kick off focused discussions on this, perhaps, that be of interest?
That sounds great, yeah.
Because, there's probably other things that we could do, like, say, looks like maybe building a documentation site and stuff like that could be useful. And, say, like, to Harish's point, like, how do you do sort of like, how do you use Waterwheel, say, for Databricks workloads or other particular workloads, how you build those stock files and stuff like that?
Yeah,
So,
definitely.
Yeah, maybe we can follow up like that. But anyway, round of applause to see. See if we can set up that channel. It's a lot of effort.
Yeah.
Up next, we've got John. Feel free to grab a slice of pizza or refresh your drinks on the kind of changeover.
Will that, sorry, Pete, will that eject from stream now? I'd love to hear or do I have to use this?
So, to get it on the screen, it's just that.
Maybe with this.
This.
What's that?
Well, we have.
Yeah. Is there an Atlassian person? It's it.
Well, I mean,
I just wasn't sure which one to use. This.
Just mute your laptop. Yeah.
Can you use my camera?
Yeah.
Or the sharing platform? Or the sharing?
I didn't see anything.
I think that was we got speakers on.
Pick up the iPad. Pick up the iPad. I think it's here.
I'll go to that side. So you just need to click your slides in presentation mode and it should come through. Yeah.
Your assumption that you
Yeah, it's one of them. Yeah, one screen.
One screen?
Yep. Yeah, get up there. All right.
Got to meet up without a few technical issues there. Anyway, we got there in the end. So John Hawkins, the university, he's an Australian data scientist and author of the book Getting Data Science Done. So that's a pretty amazing achievement. And he holds a position as chief scientist for EdTech company Playground XYZ. I believe you've got a website, gettingthingsdatasciencedone.com, so that's pretty cool. Go check that out. But you're going to take us through what's in a domain. So it's a bit about feature engineering, a bit of domain-driven design in the mix there, or sort of a bit of
Not that kind of domain.
no, okay, fair enough. All right. Well, without further ado, thanks so much. Round of applause.
Can anyone hear me okay? I'm just standing back from that. Yes, it's okay, cool. So yeah, thanks Peter for giving me the opportunity. I'm sorry that you're not having your scheduled speaker, but hopefully I'm a reasonable consolation prize. In my day job, I work on machine learning models for attention measurement for an ad tech company, Australian ad tech company called Playground XYZ. But this is kind of one of my side projects, building sort of tooling for different kinds of feature engineering, and I'm particularly interested in URLs. And so the reason being that they're structurally rich in ways that a lot of people don't necessarily acknowledge. So actually, before I start, how many people here kind of are working with data science teams? So sort of feature engineering forms some part of their role? Rough show of hands. A small proportion, okay? And how many people here are kind of familiar with the notion of a feature for machine learning? Roughly 50%. Okay, cool. So the idea is that of a feature is it's specific techniques for preparing data for machine learning models. So the idea is that different kinds of models have their own sort of biases, I guess, like human beings, and they like data to be prepared for them in certain kinds of ways. And we can actually boost the way these models work by preparing data specifically for them. So often we're trying to sort of surface the information content in that data. And so really the goal of feature engineering is often maximizing that information content for the ML model. So, and the reason why URLs are a topic that's particularly interesting is because they're structurally rich and they're sort of omnipresent. They describe how human beings interact with all kinds of computer systems, as I'm sure everyone here is aware, but also in a kind of an era of microservices, increasingly how different machines may interact with each other as well. So there are many problems where a URL can be present as a key piece of information. And in low latency applications, often the URL might be probably the most important piece of information, because if you need to make predictions about something quickly before you have a chance to collect other information, URL is going to be sort of one of the main things that you have available. So there's also a but attached to that, and that is that URLs require some element of domain knowledge to do this kind of thing well. So it's typically it's not necessarily something that data scientists will do a great job of unless they sort of come through, say, software engineering, web application development. They might not be aware of all the different ways that you could sort of milk data out of a URL. So it's a topic that's worth kind of investigating. So the structure of the talk is, I'll give you a bit of an overview of the potential structure inside a URL. I'll go through these components and talk about the kinds of ways that you can pull different pieces of information out of them. And then I'll finish off with the part that's kind of a little bit data science-y, sort of a side project in running a bunch of problems through trying to make predictions just on the basis of URLs and looking at where information comes from in those URLs. So I know for a lot of people in this room, this is all sort of revision, but just sort of talking through it, one of the interesting things about the URL is we can break it down into these different components. And it's worth noting two things. First of all, not all these components are always present in every data set. So sometimes the URL will not have the protocol. It'll just be sort of everything from the subdomain forward. And the parameter set is not always there. So sometimes it's just if it's a bunch of static resources, you may not have them. But this overall structure applies that you'll have some protocol determining, the kind of resource you're accessing and the protocol by which it will be accessed. A host, which can take many different structures. A path to the actual resource you're trying to access, which has its own properties, and then some optional set of parameters that maybe configure how you access and what you want from that resource. So if we go through these things iteratively, the protocol, so for examples, could be HTTP or HTTPS, could be FTP or FTPS. So you can see, these are just small examples, but you can already see that you can think about, there are sort of orthogonal information dimensions here. You can talk about, what's the purpose of the protocol, sort of transferring files or web documents, or is it secure or not? So these are kind of really simple ways that you can encode information inside the protocol. But then you've also got a really long tail of protocols that have come and gone, like Gopher, for instance, which at one point was a kind of a potential for HTTP, but it has been replaced, but it's not extinct. It still exists out there, and so you will encounter it in some data sets. So, which brings us to another way that you can potentially encode information, which is thinking about the frequency of usage in data sets. So something that data scientists commonly do is have a procedure that says, when we look at this kind of categorical variable, a protocol, we might encode that with the frequency with which it occurs. But we could also think about, let's look at the frequency with which it occurs in the wider internet, because that gives us something that potentially generalizes beyond just the data set we've collected at this point in time. But the problem is when you start thinking about the frequency in the broader internet, that's a moving target, because actually these protocols have been coming and going in waves. So then from a sort of feature engineering perspective, any sort of data pipeline that's going to transform this, your training data and scoring data, needs in some sense to be aware of the point in time you're pulling that URL from, so that these frequency-based encodings are sort of relative to that data point. Does that make sense to everyone? It's worth sort of dwelling on that if it's not clear, because a machine learning model, when you train it, it's trained on data from a particular point in time. As you move forward, you're applying it, and you may say we've got a universal representation of the frequency of protocols, or we might want to have something that's time sensitive. It's about, is this protocol something that was commonly used at the time when I'm scoring the data? Yeah. So there are two different ways that you can encode a lookup table for that kind of frequency data. I'll come back to that point again. Hosts. So many different structures you could have here. It could be, your sort of standard www subdomain and then a top-level domain, of which there are many. Sometimes the subdomain is optional. There are other alternative subdomains commonly used for different kinds of tasks. the host could just be an IP address, and you've got a sort of optional protocol. So that procedure we went through before, where you can look at sort of logical components that you can easily encode. Is this host an IP? Does it have a subdomain? Does it have a port? Really sort of simple to apply. But you can also think about that process of what kind of external data could I use to create lookup tables. So I could look at the year of domain name registration, like is this domain been around for a while or not? I could look at things like is it actually a publicly registered domain name, or is this just the name of a server in an internal network? We can use things like whois or DNS lookups, which are rich with other information about the sort of networks, the number of domain name servers. Is there sort of other things attached to that DNS record about how that domain's being used? And all of those things incur additional costs. So you have to be sort of, if you haven't seen that domain before, you have to sort of make those requests, or you have to build up a library of these data sets that you can use in the data processing pipeline. And there are some interesting alternative ways. So the trade-off there is latency costs of doing all these DNS lookups to get rich features versus the being able to sort of respond fast when you need to for that particular feature set for that particular problem. So some alternative strategies you can look at. The age of a domain could be useful, but if you've never seen the domain before, you don't want to incur that whois sort of call lookup. You could build up a data set of, say, things like the year in which top-level domains got released. So it's imperfect, but it can give you an upper bound on domain registration, because the registrars are releasing new top-level domains over time, so it places an upper bound on the potential age of those domains. Now, it's not going to matter if your data set is all .coms and .nets, but if you've got sort of this long tail of new sort of .ios, etc., then there's some potential to have some sense of the age of the domain. Yeah? It's a trade-off, a way of getting some information but without incurring the latency cost. Path and file. This is sort of everything after the domain is basically giving you a sense of what is the specific resource the person's trying to access. And this can take many different flavors. So it could be a static resource. So it's a file on a directory service. And so that path is actually pointing to the structure of a structure that's on that server. And there could be information in that path, like is it relative to sort of the Unix user's home directory, or does the path contain certain keywords? So you can think about semantics. This is the kind of stuff that data scientists do all the time. But it could be a dynamic resource, so something that's actually generating content, and that can be the file, obviously itself, dynamic, like a dynamic file that generates the content on the fly, but the entire path, which I'm sure everyone here knows, could also be not reflecting a structure on a server. It could be part of the internal logic of the application that's generating it. So there's opportunities here, particularly for people who understand these web servers, to think of ways to generate features that reflect aspects of the underlying application that's generating that path. Is that clear to everyone? Yep, I'm seeing some nods, which is good. Cool. Finally, the parameters. So this is everything after the question mark. Again, entirely optional, but these can be So the oldest version of this was just a set of sort of name value pairs separated by ampersands and equal signs. But increasingly, you see lots of applications for that hash character and a long string after it. So I know, for example, in Gmail, you see they seem to be controlling a lot of their application structure with the stuff that happens after the hash. And so increasingly, particularly if you're doing ML on web applications, there's a lot of information contained in the parameter set. So similar kind of things as we spoke about before, you can have flags that indicate other encoded characters in that set. So particularly in, say, internet security, in identifying if the parameter set contains an encoded URL is really useful, because that's something that sort of spam and phishing and malware URLs contain a lot. Even looking at the number of parameters and then thinking about bespoke pattern matching for something about the application logic is a good way to do feature engineering on those URLs. So sort of lots of strategies I've kind of flown through here. You can use each of those URL components as actual individual categories in and of themselves. by sort of first breaking it down. You can identify common and rare usage of components, and that can be the protocol, the subdomain, the top-level domain. It could even be things like the file type, so like HTML versus like Cold Fusion. I don't know if anyone remembers Cold Fusion. So there are many different sort of categorical elements inside a URL that you can apply standard sort of data science techniques to. But then there's a whole bunch of sort of domain-specific stuff using things like whois and DNS lookups to craft features specific to your problem. The semantics I spoke about, which is looking for keywords in the path. Then anything you can do to recognize patterns inside that parameter string, and then applications I spoke about before, where you can try and trade off between sort of latency and information access. So the example I gave was, rather than doing a full domain name lookup, using the age of the top level domain as a proxy or upper bound on the potential age of that domain. So lookup tables is kind of a big part of this if you want to do sort of more interesting, rich feature engineering. The functional stuff about like, is it secure, is it file traffic, etc. Fairly easy to do. You can build that into the process. Then static reference data, like building up a data set that says when was this domain registered, how many domain name servers does it have, are there any other kind of, what other sort of attributes are attached to that domain in its DNS record, require building a sort of static lookup table. But there's also potentially for dynamic lookup table. If you want the application to be time sensitive, reflecting the fact that the frequencies of these aspects of the URL are changing through time, you need to both have these lookup tables, but also make sure the data scientists know they need a timestamp when they're doing the lookup for the feature, because it's time-sensitive data. And then I already spoke about the top-level domain release dates. Awesome. So I have an implementation of some of these ideas. Open source, it's a simple Python, both command line application and Python package. I wanted it to do as a CLI, so the idea is you can just feed a data set in, you set a bunch of command line parameters, says which subsets of features you want calculated, and it spits it out for you, and then deals with sort of arbitrarily large data sets through chunking. I won't demo it because it's nowhere near as impressive as what Steve just showed you, but it's there if you want to play with it. And so I'm going to finish off with a little bit of blasphemy and show you some data science in this data engineering talk. So I've got a little side project where I've just been trying to understand what aspects of URLs have impacts on different kinds of classification problems. So this is like 6 open source data sets. The top one, SciSkill, there is basically, it's a sort of a personalization data set. It's basically someone's preferences, given a bunch of URLs, they've looked at this, they said which ones they like, which ones they don't. The WebKB is an old data classification data set about, given university URLs, classifying it, is it a curriculum homepage, is it a staff member homepage, is it a student homepage, etc. The spam, phishing, and malware should be obvious to everyone, just different categories of kind of internet security. And the DMOZ is another classification data set, much larger, far more categories. So, and what I'm basically doing here is I'm showing you the strength of the color underneath the sort of component of the URL shows you how much information the model was extracting from that part of the URL. So the gray line is kind of a catch-all where I do some just general sort of statistics on the whole URL, like the length of the URL, the number of sort of non-alphabetic characters, etc. And then each of the green boxes, I've extracted a bunch of features from that part of the domain, and then the model is either making use of it or not. So I think one of the interesting things about this is that different problems pull data from different parts of the URL, although you can see some commonality. So it's interesting, for example, that the subdomain appears to be useful in all of the internet sort of security problems. And that's largely because, particularly in phishing examples, what fraudsters do is they'll register some arbitrary small forgettable domain, but they'll craft in a big subdomain that looks like a well-known brand. Like they might go commonwealthbank.abc.zy.com, for example. And that's part of the kind of social engineering they use to trick people. So subdomains, very useful seem to be very useful in all kind of internet and security problems. Whereas classification tasks like the DMOS one, where you're categorizing the content of web pages, seems to largely be, well, there's more value in that path, seeing how they've structured the directory, or potentially it could be the application structure if it's in a content management system. That's giving a lot more information about what that URL means than the subdomain, for example. Yeah. Summary, URLs are very rich in information, and they're, some of it can be extracted using standard techniques, but sometimes sort of domain knowledge is really, really useful, particularly for people with an engineering background like yourselves. I think this is one of the ways that feature engineering on URLs can be improved massively. Some of these techniques require supplemental and reference data, and then you need to go through a process of thinking what are the requirements of getting that data and keeping it updated and making sure we meet the latency requirements of the ML model. And then analysis does suggest that it's not sort of a one and done problem. Each different kinds of tasks extract and rely on different pieces of information within the domain. So thank you. I hope that was useful. On my GitHub IO, I've got a bunch of sort of links to my open source projects, and I have a book out if anyone's interested. Any questions?
Awesome. Round of applause. Thank you. Just noticing the out there, there's just an absolutely spectacular sunset going on. You folks are quite lucky here at Atlassian to get to experience this in the summer. Yeah, so any questions for John? You know, it's quite an interesting talk on feature engineering just over here. Yeah.
Yeah.
How is the data very on the models?
On these models?
Yeah.
Yeah, so these were fixed data sets that haven't been put into production. These are like, I was just grabbing open source data that I could use for this, because my main interest was comparing the importance of features between tasks. So it's not something I checked.
Okay. Coding is difficult, right?
Data drift is difficult, yeah. Yeah, I mean, it would be interesting actually, those data sets don't have timestamps, but it would be an interesting exercise to get a large data set of URLs with timestamps and build the models on the earlier data set and then look at the feature importance drift potentially. Yeah, that's an interesting suggestion. Yeah.
Just wanted to understand a bit more about the use cases, like in the real world, like how would organizations be able to take advantage of like the sort of modeling that you're doing?
Yeah.
It's quite new.
Yeah. So the in all of those security applications, it's really standard for. So first of all, most of these applications don't just use the URL. It's only. Oh, sorry, I should be back on the mic. It's only, you can think of applications that are super time sensitive, where you're maybe trying to make a response as soon as someone makes a request for a different URL. You'll have like their IP address, a timestamp for the request in the URL. You have a few pieces of information, but the URL is probably the most structurally rich of all of those. In a lot of internet security applications, say for example spam or malware detection, you'll have both where an email came from and the content of the email, but the URL itself embedded in that email is a very rich source of information for identifying potential malware or potential phishing attacks. So that's why this is a really valuable type of feature engineering to explore. Does that answer your question?
Yeah, and maybe that is maybe extending to marketing. Your
Oh yeah, okay. So yeah. So I guess I'm interested in this because content, like contextual based marketing is interesting, like making sure you put ads in pages where the person you're trying to reach is likely to be reading it, and it's not, so being able to classify web pages and know exactly what they're about, and that, to a sort of fine level of granularity or mixtures of topics, that kind of stuff, like the URLs potentially, it's one source of signal. Yeah.
If I can suggest, instead of the age of the domain,
Yeah.
to look at when the last owner was changed.
Yeah, awesome. Yeah. The who is record's really interesting because I realized that I looked at one specific piece of data in that, and you've got like when the last registration was, when the registration's due. I didn't even think about like the change of ownership. That's awesome. One of the challenges with who is records is they actually seem to vary because different registrars so I guess control. I don't know how that process works. But if you do who is on a bunch of different top level domains, you'll see a lot of variation in the structure of the records they return. So parsing those things is actually quite painful.
Darius?
Yeah.
Many companies are using multiple domains to increase their brand power on the internet. Do you think it's the right strategy, or do you have other strategies as well?
I don't really have an opinion on that. Sorry. Anyone else free to answer?
Outside of this wheelhouse. Did you have a comment or question?
I have another question.
Yeah.
So since URLs are basically text, did you went through any natural language processing processes to try to clean the URL prior to making it configured?
In this example, no. Well, so other than I'm doing, so you mean, I guess for those who are not familiar with it, it could mean many things. It could mean just simple things like sort of lowercasing everything before you process it, remove punctuation. Natural language processing also can mean things like correcting commonly misspelled words or reducing words down to their sort of truncated form. I'm not doing that in this example. There is a lot of people who focus on applying standard NLP techniques to URLs. I'm kind of I'm interested in laying the groundwork because I think that URLs contain more information than just the text. So what I'm kind of suggesting is even if you're using text-based processing techniques, all of this other stuff can still supplement it because like the text-based processing can never pick up anything structured like the whois record or the DNS record or that kind of elements. Does that make sense?
Yeah. Like I was thinking it in a way like using NLP to process it,
Yeah.
and then make it a feature,
Yeah.
and then add the other bunch of features and then do the iteration.
Yeah, totally valid approach. Yeah.
Awesome. Round of applause for John.
Thank you.
So I'll just wrap up the meetup, but yeah, really appreciate everyone turning out in such great numbers. Hopefully you found the talks quite interesting tonight. I think they were pretty awesome myself. Usually Atlassian's our last meetup for the year, generally pre-COVID, but we might see if we can squeeze one in before the end of the year. We'll just see what happens. There is a form where you can submit your talk details. It'll be more prominently put on our website at some point, but if you're on our Slack group, you can just enter your details and just, we're not super, super picky as long as it's kind of has a tangible relationship to data engineering and we can see you've got something interesting to share. I highly encourage you to sort of put a talk forward because, whether you're starting out at the start of your journey in data engineering or a total expert or somewhere in between, I think, it's the whole point of this meetup is to sort of share what we've learned and sort of grow out data engineering here in Sydney and Australia. So yeah, hopefully you're enjoying the experience so far. But yeah, thanks once again and see you next month or next year. But we'll hang around here for another half an hour to do some networking. Round of applause to ITSIC once again and Atlassian for being such awesome hosts. See you next time. Thanks you.